We have finished the theoretical part of the first lessons. If you want to increase your English vocabulary, listening skill, and mathematics knowledge, you should watch my videos many times until they make sure you can comprehend everything. I talked as clearly and slowly as possible to make it easier for you. English is difficult. Math is difficult too. So when combining them, it becomes extremely difficult. So you should pay your full attention while seeing those lessons. But theories are not enough. You should practice as many exercises as possible to apply what you learn to solve problems. Therefore, it surely maintains your knowledge. And in this lesson, I'm going to help you solve some exercise, and you should finish the rest by yourself. The first exercise requests discrimination. Which one is proposition and which one is propositional variables? To find the answers, you just look for the variable in each proposition. You see, they know variable in problem A and D, so they are proposition. Problem A, 3 plus 2 equals 7, and problem D, 2 minus square root of 5 is less than 0. They are propositions. But however, in problem P, these propositions contain variable x, so x is a propositional variable. Similarly, from there are two variables x and y, and in problem C, then we infer x plus y is greater than 1 is a propositional variables. Exercise 2 is a mission for you. I just have you read it. Repeat after me to improve your pronunciation. Determine whether each of the following propositions is true or false and state its negation. A. 1794 is divisible by 3. B. Square root of 2 is a rational number. C. Pi is less than 3.15, and D. Absolute value of negative 125 is less than or equal 0. Exercise 3 seems to be quite long and complicated, so I'll help you to handle some requests of them. Okay. Exercise 3, given some propositional enhancements. A. State the converse of each of the above proposition. Okay. If A and B are divisible by C, then A plus B is divisible by C. A, B, and C are integers. So we converse it become if A plus B is divisible by C, then A and B are divisible by C. Okay, and the next propositions: though integers ending in 0 are divisible by 5, and its converse become though integers are divisible by 5 ending in 0. Okay. Problem B. State the above propositions using the concept the sufficient condition. Okay. It's become A and B are divisible by C is the sufficient condition for A plus B is divisible by C. And this proposition: though integers ending in 0 is the sufficient conditions for they are divisible by 5. Okay. And problem C. State each of the above propositions using the concept the necessary condition. It's become A plus B is divisible by C is the necessary condition for A and B are divisible by C. And this propositional enhancement become though integers are divisible by 5 is the necessary condition for they end in 0. Okay. And the rest propositional enhancement, you have to finish them. An isosceles triangle has 2 equal medians. 2 equal triangles have equal areas. If you don't understand these propositions, ask me for help and I'll answer you later. Continuing, exercise 4. Exercise 4 is quite long and difficult, so I do some for you. State each of the following propositions using the concept the necessary and sufficient conditions. A. A number is divisible by 9 if sum of its digits is divisible by 9 and vice versa. So we use the form necessary and sufficient condition. It's become a number is divisible by 9 is the necessary and condition for the sum of each digit is divisible by 9, or the sum of a number's digit is divisible by 9 is the necessary and sufficient condition for this number is divisible by 9. Okay. B. A parallelogram whose diagonals are at right angle is a rhombus and vice versa. Okay. It's become a parallelogram whose diagonals are at right triangle is the necessary and sufficient condition for its a rhombus. Okay. The last C. A quadratic equations have 2 distinct roots if and only if its discriminant is positive. It becomes a quadratic equation has two distinct roots is the necessary and sufficient conditions for its discriminant is positive, or we can convert it a quadratic equation has its discriminant is positive is the necessary and sufficient condition for it had two distinct roots. Okay. Exercise 5. Write the following propositions using symbols for any, and there is one. Problem 8. Any numbers multiple by 1 equals that number. That means any number is an element of real numbers. That is multiple 1 equal itself. Problem B. There is a number so that the sum of it and itself equals 0. There are numbers E an element of real number so that is plus itself equal 0. And problem C is any numbers add to its opposites equal 0. Any numbers E an element of real numbers so that x plus opposite it, that means negative x equal 0. 6. Say each of the following propositions in words and determine whether it's a true or false. Okay. A. For any x is an element of real numbers, x squared is greater than 0. There are two ways. That's first way and second way. Any real number squared is greater than 0. P. There exists one numbers E an element of natural numbers. It's where equal itself. Or there exists natural number where E equal to itself. And C. For any natural numbers, E less than or equal double itself. Or there exist numbers E less than its inverse 1 over x. That means inverse of it. Okay. Exercise 7. The exercise 7 is not a very difficult exercise, so you should try to do it. Now we are going to finish the first lessons. I hope you keep my words in your mind. See you in the next lesson.